Hi guys, this is for Unit 2, Module 3.1 or Lesson 3.1, Graphing Relationships. So, interpreting graphs is the first segment about these relationships. So, we have a certain situation that occurs in life. So, let's say a delivery van, all right, starts off at its warehouse. So, at 0 hours, it's at the warehouse, okay? It hasn't traveled anywhere. And then it varies throughout the day. Okay, so the graph shows the distance from the warehouse for the day from 8 a.m. to 5 p.m. So if you look, it does increase its distance. The van increases its distance from its warehouse for this segment for that amount of time. So it's increasing at that interval. Now, if you notice, the slope for segment 2 isn't going as steep, or the rate of its change isn't as steep as before, as in segment 1. So we're still increasing, that's great, but it's a little slower. Maybe the van, because we are talking about a delivery van making deliveries, right? And it's traveling around. So maybe this is traffic, who knows? So maybe traffic, okay. So they're slowing down, who knows? But if you notice at number 3, okay, the slope just flatlines. The slope is 0, okay? This situation actually is probably explaining that maybe the delivery van is actually making a delivery. So, again, delivery. And then all of a sudden they speed up again for segment 4. Super fast. Maybe after their delivery, the guy just floored it really super fast at 70 miles per hour all the way up to the freeway and went all the way through the freeway that fast. Who knows? Um, or most likely they floored down a hill and got to the other place they were dropping off their delivery, and that would explain delivery 5, where they make another delivery. And as you can see, now their distance is decreasing. Okay, they're still moving, but they're getting closer, okay, to the warehouse. And then they make, it looks like another delivery for segment 7. They're not going anywhere. Slope is 0. And then as you can see, they're slowly coming back, okay? But all of a sudden it speeds up for segment 9 as the van gets back to the warehouse. Okay, so maybe they had traffic here, who knows? Okay, but this is a graph giving that situation or that story for that van. Okay, you can make whatever story you want. Tell you what, that could be a fun do now. About a delivery van and its relationship with. This is actually what they're talking about when they say relationships, by the way. In this situation, our relationships between time and distance. There's a relationship here. Time and distance. Okay, so that's the relationship, and that's why it's called relationships. All right, your turn number 1. At what segment did the truck start heading back to the warehouse? Okay, so look at the graph and try to figure that out. Which segment? This is about reading the graph or interpreting graphs. All right, your turn number 2. So, you and your friend are playing catch, okay? You throw 3 different balls to your friend. You throw the first ball at an arc to your friend and your friend catches it. Awesome. So, this is the first situation, okay? So, that's the first one. You throw the second ball in an arc, but this time the ball gets stuck in a tree. So that's number 2. That's the second thing that happens. Now you throw the third ball directly at your friend, but it lands in front of your friend and rolls the rest of the way to the ground. So that's the third ball, the third situation. Go ahead and match them, okay? Match which ones? Is it A to number 1? Is it number 2 um, to B? Which one? So match them, okay? That's the main objective. Talk to your group, okay? See what the graph has. Remember, your relationship here is between time and height in feet, okay? Now, this question. Which graph represents a situation where the ball gets stuck in the tree? Okay. Well, the tree is probably not on the ground. So talk to your buddies and see which one is that situation. And then after that, describe the height of the ball represented by the other two graphs. So um, talk about the height and where it ends. Okay, this is also known as end behavior. Okay, the ball right here in part A looks like it just ends up on the ground. In graph B, the ball appears to be ending right there. And graph C looks like your ball just ends right there. All right, so definitions. Now there's several types of graphs that you can be seeing here based upon real life situations. Continuous graph is a graph that is made up of connected lines or curves. So let's say a waterfall. It'd be pouring water constantly or continuously as time goes on. All right, it doesn't stop. If you were to have a hose and you were just spraying water out, and you left it on, it would be continuous. It'd be just constantly flowing water. Now, discrete graphs are not continuous and are made up of distinct unconnected points. So, for example, a number of problems correct. Let's say this is a test. Okay, if you score 0, you get 0 points. What if you score 1 point? Oh, you get it looks like 10 because it's jumping up by 30s. Well, what if I get 1.5 points right? And you're just like, wait, there is no 1.5. There's either 1, 2, 3 problems, 4, 5. Nobody's going to get 5.388, continuously eights problems correct. It's either you got 1, 2, 3, 4, 5. Don't forget 0. Okay, so natural numbers. So as you can see, they're dots. They're not connected by a line. Okay, so that usually just tells you right off the bat that this is discrete. Okay, discrete, also discontinuous. Some people say that, but we like to say discrete. Okay, so notice the difference between the two. One is continuously drawn as a line or a curve, and discrete is just a whole bunch of unconnected points. So in example 1, sketch a graph of the situation. Tell whether the graph is continuous or discrete, okay? And determine the domain and range. Now, domain and range are constant conversation pieces and later on math, especially for Algebra 2. Domain is, in this situation, involving the x values. In this situation, in our relationship, it'll be involving t. So t is our domain. Now, our range is involving our y, which in this situation is the water or the quartz. So again, your range is here, okay? So always remember domain, left or right, range, up or down. All right, so let's go to our situation. A bathtub is being filled with water. After 10 minutes, there are 75 quarts of water in the tub. Good, so let's think situational-wise. In 0 minutes, the tub has to be empty, right? No one started pouring water. But in 10 minutes, we have 75 going on here. So we're jumping up by 30s. 75 is in the middle. So it looks like, now the water, remember, is pouring continuously. Okay, and it's supposed to be a straight line. I'm terrible at drawing straight lines, apparently. Okay, and let's see what else it says. Then somebody accidentally pulls the drain plug, sounds like my daughter, while the water is still running and the tub begins to empty. The tub loses 15 quarts in 5 minutes. So we're decreasing there, here where we are increasing. Okay, but now we're decreasing. So for 5 minutes, we decrease 15. So 10 to 15 minutes. And we go from 75 and we lose 15 quarts. So 75 minus 15 is 60. So there's my daughter. And there was it originally. And then someone plugs a drain in the tub for 6 more minutes, gaining another 45 quarts of water. So 6 more minutes. So we're at 15 plus 6, that's 21. And we gain another 45, which will put us up here, right there, at 105. And again, 21, so that's right around here. So we're increasing, oops, sorry. There we go. Trying to draw straight lines on a touchpad. It's pretty difficult sometimes. All right, there we go. So we're filling back up, going on the up and up. Awesome. And after a 15-minute bath, let's see, so 15 minutes, so 21 plus 15, because we're talking about the minutes here. So the water's still full. We're just hanging out there. It's awesome. And 21 plus 15 is 36. That's probably right around there. There we go. So again, we're just holding steady, taking our bath, just enjoying ourselves. And then after 15 minutes, the person gets out and pulls the drain plug. It takes 11 minutes for the tub to drain. All right, so add on to 11 minutes. 36 plus 11, that's 47. Boop. And it's empty. Oh, sorry. All right. So let's look here. We have this graph is a what kind of graph? Is it continuous or discrete? Now, if you notice, we have constant flow of water, and I'm using lines and curvy lines at that. That's because I'm not perfect, but lines nonetheless. So this is a continuous graph. All right, so continuous graph. Now the domain, remember domain is our x. We are from starting at 0 and we end at 47. Okay, this is a 47-minute bath. So you could say 0, we start at 0, so we are greater or equal to 0, and less than or equal to 47. And of course, this is in minutes. So remember, domain is always your input, and range is your output. And we'll get back into that when we talk about functions some more. Now, a range. Again, range is our y. We have 0 amount of water, or quarts, but then we max out at 105 quarts. All right. Oops, sorry. Forgot my inequality. So it's less than or equal to 105 quarts. All right, example 2, same situation. Continuous or discrete, those are our options, and determine domain and range. So a local salesman is going door to door, trying to sell vacuums. For every vacuum he sells, he makes $20. He can sell a max, yeah, that's something to notice, of 10 vacuums a day. Maybe that's how much he gets in his truck every day. Who knows? If he sells 0 vacuums, he's going to make $0. Okay. If he sells 1, well, 1 costs 20, and these jump by 20s. Okay. So he'll get there. If he sells 2, if he sells 3, if he sells 4, notice how what happens is I'm going by whole numbers: 5, 6, 7, 8, 9, 10. But notice how they aren't connected. That's because he can't sell 1.5 or 1.33 or 1.2, and he can't. It's got to be natural numbers. Okay, nobody sells 1.34 of a vacuum. It's either you sell 0, 1, 2, 3, 4, 5, or all the way up to 10, right? So if you just look at it, we just got a whole bunch of points. That is because this is a discrete graph. Okay, so that's part 1 done. Determine the domain. So domain, again, is our x. And if you noticed, it's basically either 0, 1, 2, and he can really just sell anywhere from 0, 1, 2, 3, 4, 5, and that's what I'm doing here, 7, 8, and 9, and 10. So I'm just listing all the numbers from 0 to 10, all natural numbers from 0 to 10. Okay, so that's realistically how much he can sell that day. Now, range. Now, range is our y. Okay, so let's see. This will become in handy if you're thinking about, well, how much money can this guy make? In this situation, he can make $0. He can make $20. He can make $40, 60, 80. Notice how I'm just going by 20s, okay? And they should be matching what's happening with our domain, okay? So you can keep going up by 20s if you really want. 100, 120, 140, 160, 180, and lastly 200. That's where he maxes out. Okay, so again, this matches the situation. He sells 10, he gets 200 bucks. He sells 0, he gets 0. Okay, so this is how you list, especially with discrete. Discrete often doesn't have any qualities most of the time. It depends on the situation. And we start listing these numbers all broken up. Okay, so that's something common with discrete graphs. Okay, your turn number 3. So I did 2 examples, very similar to this situation. What I want you to do is determine whether this is a continuous or discrete graph, and determine the domain and range. So at the start of the snowstorm, it snowed 2 inches an hour for 2 hours, then slowed 1 inch. So notice, let's see, snowed 2 inches an hour for 2 hours. Okay, so we're increasing snow there. Then it slowed, okay, still increasing, but slowed to 1 inch an hour for an additional hour before stopping. Okay, so still increasing. 3 hours after the snow stopped, so 3 hours after the snow stopped, it began to melt 1.5 an inch an hour for 2 hours. So it started decreasing right there. So you have an increase, and then after the snow, 3 hours after the snow stopped. So for 3 hours, it was doing nothing, flatlined, just like the trucks after they make their delivery in the first example. And then it began to melt. So go ahead and graph it. Graph it, see if it's continuous, discrete, and talk about the domain and range with your group, and then let's get a general consensus. All right, guys, thank you so much. Have a great day, and be safe. Bye.